We are live again, and it's day 3. So let's go to our neetcode. So it's our neetcode. So let's go to array and hashes, and we finalize with design hash set. So let's set up our 30 minutes as usual. Okay, timer. And 30 minutes. Let's start. All right, open. And let's go. So first question, what we should do. Let's go. So we should design hash set. Design a hash set without using any built-in hash table libraries. Implement my hash set class. Insert the key into the hash set. Contains return whether the key exists in the hash set or not. And remove the value in the hash set. If key doesn't exist in the hash set, do nothing. And okay, so we should design a hash set data structure with add, and we add an integer, right, as a key, remove integer, and also contains key integer. And here we return true false. Here we just do void, and here as well we do void operations. All right, and we have some constraints, for example, like what key can be, but it's actually not really important for our case. So hash set is understandable data structure, so it's data structure that when we add another element, if it's already exists, it's actually it overrides this value. So it means that we have no duplicates by hash function. But if it's integer, actually hash function is our integer. And we see that keys can be from 0 to 1 million. So it means that we cannot use some basic array, for example, to store. And also we cannot use any built-in hash table libraries. So that's also something that's restricted here. So what can we do? So in real implementation of hash set, we have an array of integer array with buckets where we put in each bucket, we put some kind of linked list. And then we check if this value exists or doesn't exist. What we can do the simple. So if it's easy question, we can just do linked list, one linked list, and implement this function with simple linked list. So let's try to implement this. So if we have linked list, we need some record. It called node with value and node next. And we have such record. So let's say that we have node start. That would be our node with -1 and null. So it would be our dummy node, actually, that we start. And what we should do here. So when we add in our element to linked list, if this element already exists, we actually do not add this value. If it exists, then we add to the tail. So let's first find tail. We can do like this. So we can take temp node that it's start, and while tmp next is not equal to null, we do this operation. And if tmp value is equal to key, we just return from this function. Otherwise, we overwrite our TMP with next. So here it's our tail function. So what we can do, we can, record here is bad because we cannot overwrite. So let's do it as a class. A class with new node with integer value and node, and also this value equal to value, and this n equal to n. This next equal to n. Yeah. So we have such class. So now, so now we have our last node. So what we can do like temp next equal to new node with key and null. So it's actually adding, right? Then removing. So again, we do like this, but here, we should do until TMP is not equal to null. Yeah, and when so we should have kind of previous. So we do like start and when previous. So previous not equal to null, and we do like this. Previous next not equal to null. So if previous next value equal to k, then we should do this removal operation, and here we should do return. So how we do removal operation? So we understand that the previous next. So we should just do like this: previous next equal if previous next not equal to null. We do like this, otherwise equal to null. And here we remove this node from our array. And for simplicity, we can do like this. Previous next. No, I think that should be enough. So it's removal, but here it can be the case that we are on the final node that we should remove. No, I think it's not possible, because if it's final node, yeah, so it should work for us, remove, and contains the same. We take temporary node as a start, and then while TMP not equal to null, we just iterate. Here it would be return false, and here if TMP value equal to key, we just return true. Yeah, so I think should work like this. Let's run it. Okay. Yeah, without new. Yeah, should be like this. here its value. Time limit exceeded. Nice. Of course it's exceeded because we are not. So when we add, we update our TMP, but here we also should update our previous to previous next. And here we should update TMP to TMP next. Okay, wrong answer. So at the end it should contain false. Output true. TMP next not equal to null. TMP value. Yeah, I think that when we add, it probably should be like this, right? So we are going, so we are going like this. And also we should check if TMP value is equal to key, we just return. Because it's like next, the final element. Yeah, and now it's accepted. So we submit. And we see that we are done. So let's check our submission. Okay, so here we actually done the same with linked list. Yeah, so we have our node. We created our node class with dummy nodes. Add, yeah, the same. We see like node contains. Yeah, I think it can be even done better, right? Node contains. Head next. Okay. So here we add in at the beginning, not at the end. Yeah, but I think current implementation, it's even better. Do you have some other solutions? So if we check this submission, what would be the most, the faster? Okay, so faster it's actually to use an array over 1 million elements. And then we just remove. Yeah, probably maybe array would be even better. Let's check topics. Linked list, yes. Array, hash table, hash function. Yeah, so we are actually done with hash set. Let's go to hash map. I think hash map would be even more interesting. So design hash map without using any built-in hash table libraries. Implement hash map class. Initialize the object with an empty map. Put with key and value. And get and remove. And yeah, so we have some constraints here. So I believe this is pretty much the same. Let's go to Java. It's pretty much the same. Let's reset it. And we see that it's also value that's like 1 million. So as was demonstrated previously, we can have an integer array of 1 million elements. So let's try to do this. So we have our it would be not integer. We can create some class pair, right? And pair, it can be our key and value we can store. So yeah, it's even better. So we can have like memo. And if it's from 0, okay, so we have new int 1 million elements. What we should do in the beginning, we should iterate over our elements and set them as -1. So we just iterate over memo length. and set in our memo -1. And then we just put under key some value elements. So we just do like memo key, we put value, we get from key, so it's not, if it's not exist, so we just get like memo key, if it's equal to -1, if it's equal to, yeah, I think we even can just return from here and remove, it's actually memo key -1. So I think it's more or less that what we need. Let's go. Yeah, it's accepted. Let's submit. Okay, it's out of bound because we need maybe one more. Okay, and we are done. What we have here, yeah, so we have here array list with hash functions, yeah, pretty much more complex. Here we have nodes, buckets. Yeah, actually this implementation, our current implementation, not a real hash map, right? So with hash map, we need some buckets, and under this bucket, we need an array list. So yeah, this could be more, it could be better, but I don't know why it's better. It should be still pretty fast. Here we have implementation of these buckets, like 10,000, no, 100,000 buckets, right? And we see that under this bucket we have nodes, and we remove this node, we get, we put, so yeah, so quite complex one. And here, yeah, it's something that's similar that we actually done here. So let's not go to these buckets because it looks like complex, but actually this task is easy. So let's go to the medium one. I think it should be more interesting one. So we left with 12 minutes. So sort an array. We are given an array of integer nums. So let's write it as our nums. So first, about definition. We are given an array of integers. We should sort them, and we should sort in ascending order and return it. So ascending order, it means 9, 8, 7, 4, and 1. And here, for example, we have 8, 1, 4, 7, 9, and we should return a sorted array. You must solve the problem without using build function in n log n time complexity, and with the smallest space complexity possible. All right, so we have our definition. Let's think about constraints. So let's check our array length. So I believe it can be from, yeah, we have from 1 to 100,000. What about values? So values actually doesn't matter, and even if we have duplicates, I think it's fine. With test cases, I believe if we have empty, we don't have them. If we have one element, we just return this one element. If we have multiple elements and they are not sorted, we actually should sort them. If we have same element like 4 times, we return this 4 similar elements. If we have this one, then we return our sorted array. So pretty much understandable. About approaches. So the first approach, most simple one, we just have 2 loops, and we every time we go from the beginning to the n-1, and we find the maximum value into our array and put in the end. So it's n squared like it's kind of bubble sort, and we use 10 and squared, and as it will be constant space complexity. About more optimal sorting, we can use merge sort, for example. So how merge sort works? Merge sort, we divide our array into two subarrays, and then we merge them together. So we first do the following steps. So we have unmerged array, right? In the beginning. We have unmerged array. So we should split this array into two parts. And here it will be 8, 1, 4, and 7, and 9. When we have one or two elements, we actually can merge them. We can start merging these arrays. But here we still continue to split. So it would be 8 and 1 and 4. And here it would be 7 and 9. This one is already sorted, this one is already sorted, and this one is already sorted. So we can start merging our array. So we have 1, 4, 8, and here we still have 7 and 9. Then we merge this array 1, 4, 7, 8, and 9. And we at the end have our sorted array. How it should look like in the code. So in the code, it would be like sort function that receive our array. Then in our sort function, we need to make some division and split. So let's say that we need some merge function that will return array 1 and array 2, right? So let's have that we have, instead of also we have this merge function that receive array 1 and array 2, right? Okay. So we have two functions. Then we need also split. We need also split function that split our array. So we receive our array and we split from I to J, and from J to another array. So we actually, what we do, we yeah, so what we do here, let's think. Sort, we have 7 minutes, so let's finalize with this question. We have sort functions, then we need to split this array into two parts and then call merge over two parts. And we should do it recursively. So I believe that we need another sort function where we will split our array into two parts, and we'll call this recursion function. So let's call it recursion function, where we have array from some I to j and from j to k. From I to j and from j to k. Okay, and then in this recursion function, we do the following. So we have 3 positions. So we should check. So if j minus I, it should be 2 positions. And then in recursion, we call this 2 times, and then we call, we should call our merge function, because this recursion, it would be from 0 to array length divided by 2, and here from array length divided by 2 plus 1 to array lengths. And here we have array 1, here we have array 2, and then we call our merge function over array 1 and array 2, and we return. Yep, but I think actually that we need to call this to function inside here, because at the beginning we just need to call recursion over array from 0 to array lengths, and we should return this. And then here we call it 2 times. So first one, it put it from I to j divided by 2, and here j divided by 2 plus 1 to no, it should be not always like this. Okay, yeah, because we can have something like this when we divide, right? So we have I and j, and then we should like take from here to here. Yeah, so I think this one is not correct. This one is not correct. So it should be like j minus I. No, it should be like from I to j minus I divided by 2, something like this. And here it should be from j minus I divided by 2 plus 1 to j. And then we have this merge function that's actually doing this merge. And in recursion, if yeah, we should create here. So if j minus 1 is equal to is less or equal to 2, then we actually return here. We can do like this. So if it's equal to 1, we return new int, and we just take I and j equal to 1. So in which case it can be like 0 and 1. No, if they equal to 0, if it's the same, yeah, if j is equal to I, we return new int array I, let's say. And if j minus 1 is equal to 1, we return new int, and here we return the maximum. It should be from maximum to minimum, right? So the maximum from array I and array j, and here we return the minimum from array I and array j. Yep. So here we have 2 arrays, and then we just need to implement our merge function. So our merge function should look like this. We take 2 indexes, I and j, and then we have two arrays right from here. And if I is equal to array 1 length, and we need to merge. So we need actually to create a result array with array 1 length plus array 2 length. And here, if I is equal to, and we need to, is I is equal to array 1 length, we put into our result I plus j, array 2, and j plus plus. And here we should do like this, while j is less than array 2 length. We do this operation, and the same we should do for the second array. So we do j array 2 length. Here it should be I and array 1, I, and that's it. And here, not while, but yes, so here it should be like this, while I plus j is less than result length. Like this. And here else, here should be else, and else it means that we should take the maximum between them. So we just take if array 1 I is greater than array 2 j, then we just put into our result I plus j, we put array 1 I plus plus, else we put into result array 2 j plus plus, and at the end we return our result. So so I believe it should work something like this. I think we don't have time to debug it, but let's try to implement it. So we need this recursion function and merge function. So first it will be our recursion function, so it's actually return our result, and our recursion function accept integer array I and j, and here we just return from this recursion, we take nums 0 and nums length. So what we do here in this recursion, as we told, we do the following. So here it will be array 1, here array 2, and we also need to implement our merge function. So merge function is also returning array. It's merge. It receives here array 1 and array 2. And do this merge function. And return result. So let's try to run it quickly. Well, let's remove everything. And let's fix something. Okay, so let's do like this. Let's run once again. All right, line 10. If, okay, so I believe something like here, it's not working. Array ij. Here. We also miss with semicolons. Here, method rec in class cannot be applied to given type. Yeah, because we also need array. Okay, index out of bound. Index out of bound. Yeah, because probably we need -1. Stack Overflow, recursion. Yeah, I think we don't have in this base case operation, so we go from I to J. From I to J, J -1 divided by 2. I think maybe plus I. Yeah, I think we didn't solve it, so let's stop here and see you tomorrow.